So guys, today is the experiment about enzyme activity. We'll test enzyme activity for effect on the pH, on the substrate or the reactant concentration, and the enzyme concentration itself, correct? But before we start, what does the enzyme do inside our body? Somebody will tell me. We have an enzyme. What does the enzyme do? And then why those enzymes are very, very important. As you can see, the enzymes are breaking up larger molecules inside our bodies, like lactose, galactose, and glucose, correct? That's without the enzyme lactase, it will be very difficult to break them, to break those larger molecules. That's one. Then you ask yourself, what's the purpose of enzyme? What if the enzyme is very active? Somebody will tell me. It turns out the enzyme is a catalyst, speeding up the reaction without being part of the reaction itself. So enzyme is chemically called catalyst. Catalyst, any chemical that's really speeding up the reaction without being involved in the real reaction. So at the end of the reaction in our bodies or elsewhere, this catalyst or this enzyme can be recovered as is. Nothing happened to it. So it looks like speeding up the reaction, the enzyme and the catalyst, the enzyme inside our body, but the catalyst outside our body called catalyst. But their purposes and their functions and their all ideas are the same. All this is the same. The catalyst is lowering the activation energy of the reaction. Same the catalyst and the same the enzyme. So the reaction will have less activation energy and proceeds. The reaction proceeds very fast. Everybody's following? So lowering the activation energy of the system, of the chemical reaction, that's we call it system, and by lowering this, speeding up the reaction. But the good thing about catalysts and enzymes, they are the same thing. Inside the body, we call it enzymes. Outside the body, we call it catalyst. So for living matter, we call this enzyme. For non-living matter, we call it catalyst. Now, those catalysts or enzymes, whatever is the topic is, outside the body or inside the body, those are lowering the activation energy of a chemical reaction inside our body or outside our body, and therefore they're speeding up the chemical reaction without themselves being involved in the reaction. At the end of the reaction, you can recover this catalyst or enzyme, catalysts or enzymes as they are, correct? So today we'll have the opportunity to follow the enzyme activity. We will not have the lactose, which is a large molecule. Lactose, the problem is a white crystals. When you dissolve it, it has no color. So we will have a color compounds mimicking the lactose, but when this dissociate, it will give us a colorful compound, correct? So this is the reaction we are pursuing. Lactose, this is the large molecule. Here you have, guys, this is lactose, and you can see lactose is made of glucose and galactose. What's the difference between them? Somebody will tell me. Somebody can tell me what's the difference between galactose and glucose? Well, it turns out that the OH position of number 4 carbon, if it's up, that's galactose. If it's down, that's glucose. So down, this one up. Are you following me here? Very, very small difference between them, which is the OH here at this position. If it's down, that's glucose. If it's up, it's galactose, correct? So they have very similar chemical reaction and physical properties. very similar. However, the position of the OH, the number 4, is up, is galactose, down is glucose. Now, we cannot follow the reaction, the enzyme activity using this molecule. Why? Dissolving it as a solution will lead to colorless solution. It's very hard to follow. However, we'll be using spec 20 as you have it on the bench. I'm not going through the details how to use it, but I will come to every group showing how we can do it. It's not difficult. So let's save some time on this. So instead of taking the whole molecule here, we are taking one that yields for us a colorful compound, which we can follow by the spec 20. Spec 20 is always related to absorbance of a colorful solution with its concentration. So the intensity of the absorption of this colorful solution related to its concentration. As you can see, the higher the concentration, the higher the absorption. Correct? So let's take this one out. Instead of this lactose, which yields a colorless solution of galactose and glucose, that's not helping us in following the enzyme activity. Instead, will be taken one compound that's really has a colorful compound. So we will have this yellow solution. We can follow its concentration versus the absorption of the light. It's a yellow solution, and with different concentration, you can see the absorption, the intensity of the light will be direct proportional to the concentration of this compound. Galactose is colorless solution, has no use for us. We cannot follow it. So, and this is the large molecule here. You can see ortho means 1,2 nitrophenyl. Okay, this is 1 and 2 nitrophenyl, correct? Beta D galactopyranoside. So this molecule here has the large name, which is abbreviated from now on ONPG. So that's the abbreviation of it's used by your procedure. ONPG stands for the 1,2 or ortho nitrophenyl beta D-galactopyranoside. Okay, so this compound here with the enzyme called lactase. The enzyme. This is the enzyme here. And the enzyme will break this one here to colorless solution of galactose and colorful yellow color of the anion. So the anion, that's the nitrophenolate ion, and you will see it has a yellow color, and the intensity of this yellow color will be direct proportional to its concentration inside the solution. So that's the very important part of the reaction. So what we are doing in this reaction here, we'll be following first the concentration. We will do it in 3. As a matter of fact, we can make 4 features or 4 factors that the enzyme activity will depend on. The enzyme concentration, the enzyme activity depends on the enzyme concentration, the pH of the solution, the temperature, which we will not do today, and the reactant, the substrate. This is called what? We call it substrate. Substrate, which is equal to reactants. In the enzyme or in the biochemistry, substrate or reactant are called substrate, which means reactant. Correct? So this reactant will be decomposed by lactase enzyme into 2 components. One is colorless solution galactose. Galactose has a OH up, glucose down. And this here is very important for us because it has a yellow color with its intensity, which is direct proportional to its concentration and direct proportion to absorption of light. Okay, guys, that's the whole idea. So we will have three, we'll not do the four, we'll do three dependence on some activity on those three factors. Those are here the three ones. So we'll do the first one here. The enzyme activity is direct proportional to enzyme concentration, meaning the higher the enzyme activity, the higher the concentration of the enzyme, and vice versa. If you increase the enzyme concentration, the enzyme activity will go up. And the pH is totally different. The pH has a maximum or optimum pH. That's the enzyme activity or the enzyme itself will work on. So the enzyme is not working on all the pH. The pH is what? It's the scale of acidity and basicity of the solution, correct? So not all the enzyme and not every enzyme will work in all type of the pH. This is the optimum. The optimum. Maximum enzyme activity are obtained at this maximum pH. Now the third one, we'll do the substrate. The substrate, which is our substrate? The substrate is our reactant concentration. The higher the substrate, the higher the enzyme activity to this point, then start leveling off. See here, then start leveling off as no effect. So the enzyme activity will increase to the point that afterwards it will have no change on the enzyme activity, correct? So number 4 we will not do, which will do the enzyme activity here, enzyme activity, and this is temperature. Now the same thing with the pH here, you can see there is optimum temperature for the enzyme activity to work on. The enzyme will not work in every temperature. So we'll not do this, but at least you know the pH and the temperature is related by the optimum of their values to the enzyme activity. We can't say that the higher the concentration, the higher the pH, or the lower the pH, the higher the activity. No, it has to have an optimum, and this is the same thing. There is an optimum here. So temperature and the pH is very, very crucial for the enzyme to work. Without optimum temperature, without optimum pH, the enzyme activity will be very, very low, very, very low, correct? So those are the three ones. We'll not do the temperature, but we'll do enzyme concentration, the effect of enzyme activity on the enzyme, or the effect on enzyme concentration on the activity, its activity, the effect of the pH on the activity, the substrate concentration effect on the activity. So those are three ones, no temperature, as you can see, and the substrate here, this word substrate means reactant, and we mentioned that here. This is our substrate. I tell you what our substrate is. This is our substrate, which is equal to reactant. Okay, guys, and the enzyme we are using, lactase. That's the enzyme. So let's do first the effect of the enzyme concentration on its activity. As you will see, the higher the enzyme concentration, the higher the activity. That's always, even the catalyst. So let's take this one here. first one. So the first one here means this is high, the enzyme activity will go high. Correct? This one is high, the enzyme activity will go high to the limit to up to here, then start leveling off, has no effect. Correct? So, and then the pH, it has to have optimum pH. Temperature here, if you put T, and here the enzyme activity is the same. You have to have optimum temperature. So we'll do those three, we'll not do the temperature. So let's start with the first one. Let's start with the first one. So the first one here, I'm not going through the spec 20, I will come to show you in person each group. It's not really difficult to do. We'll not waste our time explaining the spec 20. I can show you in doing this in person. I'll come to each group. So the first is you have to check the enzyme concentration on its own activity. We said the higher the enzyme activity, the higher the enzyme concentration, the higher the enzyme activity. So you will prepare 4 different concentration of the enzyme, 4 different concentration of the enzyme. So how I know those 4 different concentration? Well, this is the most diluted one. Most diluted one, and this is most concentrated one. This is the 4 test tubes with 4 different concentration of the enzyme. So the enzyme is kept at 1 ml, it's not changed. So in all those 4 test tubes, the enzyme is kept to be 1 ml. Now, if you can't measure the 1 ml, 1 ml is exactly, not exactly, approximately, so 90% is about what, 20 drops. 1 ml, how many drops? 20. You don't have a graduation that measure exactly 1 ml, that is 20 drops. Correct? So the 2 mLs is 40 drops H2O. So this is, the H2O is large, so this is most diluted here. The H2O is the least, so the most concentrated test tube is this one here. Correct? That's the most concentrated. And test tube 1 is the most diluted one. I have markers. You can mark your test tubes 1, 2, 3, 4 with this 4 different concentration of the enzyme. Correct? And we are about to have this concentration. This is the concentration of the enzyme concentration, and this is the enzyme activity. Goes up. So we have 4 different concentration of what, of the enzyme, correct? From most diluted to most concentrated. So what we will do with those 4 test tubes, we have the enzyme, but we don't have the reactant, the substrate. So we'll come here, we'll make ourselves, we'll add substrate to that. So what will happen here, you will have, first you will have your reference or the plan. Before measuring the spec 20, you have to enter your plan. It's very important because without the plan, then your data is not, does not have any reference and is not worth it, so it's worthless. So you have to do the blank. The blank here is made of 3 mLs of the buffer. You add the buffer 7, correct? All the chemicals are in the back or inside near you. So then you will take the reactants here, the substrate, 0.5 mLs. Somebody will tell me how many drops of 0.5 mLs? Somebody? 1 ml is 20. Half a ml will be what? 10 drops, correct? 10 drops. And 10 drops of distilled H2O. So I hope you have a graduate scheme that's much better than just adding the drops. So that's your reference. Before you start any measurements, you have to enter your your blank. The blank is telling the equipment with spectral 20, this my data is related to this reference, to this what? This is my reference here or blank, correct? And it says what what the wavelength you have to put. I think the wavelength is given to 420 nanometer. You'll find it somewhere here at the beginning of the whole thing here. It's 420 nanometer is your working spectral for this experiment is 420. Here it is, guys. 420 nanometer is, you said the wavelength, correct? You said the wavelength of the absorbance of the light by your solution by 420 nanometer. It says in the equipment wavelength, so you put it 420. That's very important because that's the maximum absorbance happens at this, and this is done by experiment. So this is done by experiment, but it's already done for you. So it's already done. You don't have to do the experiment, but you can do it by experiment. So now let's go back here and then look at what we have to mix. So those are the 4 test tubes and 4 different concentrations of the enzyme solution. The enzyme is not is fixed 1 ml, 20 drops, but the amount of H2O is decreasing. 1 is the most diluted, the number 4 test tube is the most concentrated. Now, we'll do, this is our blank. We have to start our SPEC 20 by entering the blank. Okay, enter first, you do the blank, take the blank out, which is, this is your blank. And in our blank, you will use the test tubes. Those test tubes up to three-fourths of them filled with this. So this is the reactants here. This is the reactant or the substrate. Same thing. And you'll add all this together. The buffer solutions are near you there in a container. So that's your blank. Before you start measuring anything, you will have your blank in to test it. So you put your blank and you will not do anything else. So you do your blank, and then after doing this, the software inside will get this as a blank, and then you will have the most diluted one, sample 1, test tube 1, correct? You will add half a ml of the enzyme solution of test tube 1, the most diluted one, half a ml of substrate reactants or LPG, and 3 ml of the buffer pH 7. So this is test tube 1, correct? This is test tube blank, call it blank, okay? That's your blank here. This is your blank. Now this is a new test tube 1, new test tube 1. If you don't have enough test tubes, just dump the whole thing in a waste beaker. Have a waste beaker near you, dump whatever you have, rinse them with distill, and reuse them. You don't have to dry them. You don't need to dry them. Just dump whatever previous experiment inside them, inside the waste beaker. Rinse them with the distill, not tabor. Don't touch the tabor until the end of the experiment. Every time use distill. So, and this is test tube 1, correct? This is test tube 2, 3, and the most concentrated one will be number 4. So number 4 is the most concentrated one. It is number 4. Then you will do, this is without H2O at all. This is just not part of the test, the 4 test tubes you have. This is added by yourself, enzyme without H2O inside. This is the most concentrated one. There is, as you can see here, no H2O. So this one will be very concentrated one, correct? Then you just record the value. Whatever the value, record the absorbance. And those will be recorded, if you look at this, recorded inside the data here. Go back and look at the data here. That's your data here, correct? That's the blank, 0, 0 concentration, 0 absorbance. And then 5, the concentration. You can see here all the concentrations calculated for you. You just record what the absorbance. Record what the absorbance here, correct? So that's the first one. Then you got the second one is to look at we are looking at the pH. We are looking at the pH now. The pH is the same thing here. So you will have different test tubes, correct? That's your blank. The same test tubes you have, just dump whatever you have in the previous concentration of the enzyme, the first experiment. Just dump it in the waste beaker, and at the end of the experiment, dump the whole thing inside the waste barrel over there at the back of the lab. So that's your blank here. That's one test tube, your blank. Then this test tube number 1, 2, 3, 4, and then this one here you need to have. So then you have to empty those after taking the absorbance. You have to take what the value of the absorbance by all this one here, and then will be whatever number 5, test tube number 5, correct? And then those are solution. You record what? You record the absorbance. Every time you record what your absorbance, you come here. So that's the second one, correct? And even here, following 8 and 9. So from 4, 6, 7, there is no 5, 4, 6, 7, buffer solution, 7, and then 8, and then 9. All those, that's the pH. You can come here to the data here and record the absorbance. That's what we are doing. This is the enzyme. This is to belong. So this one here, depending on the data, those values here versus this value here, correct? Concentration versus absorbance, correct? So that's the first one. The second one, the pH, will come here. You record the pH, correct, to the 5 test tubes, correct? And you will do what? You will do the curve. So the first curve, we are expecting it to be, the first curve here, we are expecting it to be linear, correct? The second one, we are expecting it to be with optimum here, the pH after measuring the pH and the absorbance. You know what the pH of the solution from the data you have. And when you have it ready, and you plug all this, so you should be able to have. So then here somewhere is your optimum. Your optimum is here, optimum pH or optimum absorbance. That will be the pH, optimum absorbance of pH. That will be your optimum pH. Okay, so then the last one here is to look at the reactant or substrate or reactants concentration. Look at the concentration of the enzyme. You have to look at the substrate. So the substrate here, concentration, the substrate means the reactants, which is ONPG, the large molecule here. We'll prepare 3 test tubes with 3 different concentrations. This is test tube, the most diluted one. Here it is. Here it is, diluted one. and this is concentrated one. So 3 test tubes to test the substrate concentration on the activity of the enzyme. So then you have this one here, and you will make then your mixtures for this. Those are the mixtures, those are the test tubes here. The blank here, this is the blank. The first one is always the blank, and then you have all this concentration, all this, and then you measure what? You measure, you know, the pH of those, the pH is there, and then you will come here and enter what? Enter your values here. This is relative substrate, those are the concentration given to you. Okay, this is the concentration. You just record the absorbance, and what you will see here, blood this column here, plug this column here against this column here, correct? Concentration versus absorbance. And what you will see here, as we have seen, you will see the relationship we have talked about, increase, and then start what? Leveling off. So up to here is the maximum substrate concentration, correct? And this is of this absorbance. So something here is, which is in this point here, correct? So this is the 3 effects affecting the enzyme activity today. So the first one, let's conclude the whole thing. The first one, we are testing the enzyme concentration, the enzyme itself concentration on its activity. The second one, we are testing the pH of the solution, okay, the pH of the solution on the enzyme activity. The third one, we are testing the reactants, the substrate, the big molecule, OMPG molecule, against the activity of the enzyme. So, and you saw the graph below. The only one we are not doing is the temperature. The temperature behaves like the pH. There is optimum pH and there is optimum temperature. So I think that's all what I want to share with you. I want you to do the lab itself because the lab is time consuming. So let's do the lab. And if you have any question about the Spec 20, come and ask me. I'll be more than happy to explain how to use the Spec 20. Thank you very much.